Ramanujan for G is now available on the Google Play Store. Try it out for free.
Hello students, good morning. Now in our last class, we have seen how organic compounds are classified based on their structure, and there we have seen that organic compounds can be divided into two different classes. One is called alicyclic or open chain compounds. We also call them aliphatic compounds. These are the compounds where there is no ring structure that exists in these compounds. If a ring structure or any closed chain structure that exists that is found in any organic compound, then we put those compounds in the cyclic or closed chain or ring compounds. And these cyclic or closed or ring chain compounds, they are subdivided into alicyclic compounds, which are also called aliphatic cyclic compounds, and then aromatic compounds. Please remember that all the alicyclic or open chain compounds or cyclic or closed chain compounds, they can have branches as well. They may or may not have the branches. And what are those branches? We'll see a bit in more details. If you know, so there they can have branches or they may be a straight chain compounds, the alicyclic or open chain compounds, or they can also have branches or the side chains. And the cyclic compounds or closed chain compounds can also have substituents or the branches as well. So the cyclic compounds or closed chain compounds are these aliphatic cyclic compounds and aromatic compounds. Their examples we have already seen. So alicyclic compounds, there further these alicyclic compounds can be homocyclic, or these homocyclic compounds are also called carbocyclic because in this cycle, in the entire ring structure, the ring positions are taken by carbon atoms only, then they are homocyclic or carbocyclic compounds. And if the some of the positions of the ring, or the if they are taken by some heteroatoms, then they are called heterocyclic compounds. And the aromatic compounds we have seen, the aromatic compounds could be of three different types. One is the benzenoid, the compound based on the benzene or benzene that we know, or the naphthalene, anthracene, phenanthroline. There are many examples, and non-benzenoid compounds. The examples we have already seen, and then the heterocyclic aromatic compounds as well. So aromatic compounds can be heterocyclic as well as examples we have seen, particularly thiophene, pyrrole, furan. There are many such compounds, which are heterocyclic compounds, imidazole, and so on. Now these things we have already seen. Then we saw also the functional groups. The functional group, you look at the structure of an organic compound, what we see that some part of that organic compound which usually contains what? It contains some heteroatoms, actually determines the reactivity of this chemical compound, and that portion of the chemical compound is called functional groups. And based on the functional group, there can be many functional groups, and based on the functional group, there can be many homologous series. And homologous series means the compounds having similar structure are they are called they belong to a homologous series, and is the successive members of the homologous series we have seen there is a difference of CH2 unit. So the first member then second is different than the second member of the one homologous series only by CH2 units, and the second member to third member is also different than just the difference is only of the CH2 units. So the different functional groups that we have seen also, what are these functional groups? And these functional groups, please remember that these functional groups, there can be one functional group can come multiple times in a or in an organic compound, or there can be more than one functional groups at different positions in an organic compound. Such compounds are called polyfunctional compounds. So a compound can be organic compound can be monofunctional or polyfunctional as well. Monofunctional means only one functional group will be there in the organic compounds. If you look at the class of organic compounds, the simplest form is alkane, and we know the hydrocarbons. These hydrocarbons usually are classified into alkenes, and alkynes. Hydrocarbons, again I say only carbon and hydrogen. Hydro means hydrogen, and carbons. Only hydrogen and carbon. If any compound contains, then the compound is a hydrocarbon compound. There can be these compounds can be alkanes, alkenes, alkynes, or arenes. Even the benzene. These compounds contain only hydrogen and carbon. So alkanes, what we know, these alkanes are carbon hydrocarbons, and these hydrocarbon contains only carbon and hydrogen. as well as what is very important is there is only single bond that exists between different carbon atoms, and so these alkanes are also called saturated hydrocarbons. So only single carbon bond exists in all the kind of alkanes. If these carbon chains or carbon organic compounds or hydrocarbons particularly, if they also contain a double bond, carbon double bond, I mean to say, there can be double bond with some heteroatom as well. So there will be different functional groups that we will see. So if there is a carbon double bond and at least one carbon double bond is there, then this compound, such compounds are called alkenes. And alkanes, so at least one carbon double bond. So alkanes, what we know, alkanes, their general molecular formula or the chemical formula is CnH2n plus 2. This N can be 1 to anything. So if N is 1, so it will become C1H2n, 2 into 1 plus 2. So CH4, this is the methane that we know, and if N is 2, it will become C2H6, ethane, then propane, C3H8, then butane, C4H10, and so on. What we see, if a single double bond exists in the carbon chain, it means this single bond will be formed when two hydrogen atoms at the successive carbons are removed. Then only two valencies will be created at two different carbon atoms, and so two different p orbitals then can have overlap. And in such a case, with alkenes, if there is only one double bond, alkenes have two hydrogens less than the corresponding alkanes. If there are two double bonds in an alkene, it means that corresponding alkene will have four hydrogens less than the corresponding alkanes. And similar, three means one double bond formation means you have to remove two hydrogens to form a double bond between two carbon atoms from an alkane. And so alkenes, if there is a single double bond in the alkene, then their general formula will be CnH2n. It was for alkene CnH2n plus 2. So from H2n plus 2 minus 2, so it will become CnH2n. So hydrogen atom, two hydrogens less than that of the corresponding alkane. If there are two double bonds and two double bonds, then the general formula of that alkene will be CnH2n minus 2. So usually you might have seen in some books the alkene general formula is given CnH2n, but that CnH2n is true only for the compounds containing only one double bond. If the compound is having multiple double bonds, then their general formula will be changed accordingly, and that will be for each double bond there should be there should be two hydrogens less than the corresponding alkane, and so you can write a general formula for any alkene if you know how many double bonds are there in that alkene. Then what we know, alkynes. If in the carbon chain it was initially alkane, and if you remove, uh, you add instead of a single bond, you add triple bonds at any position. And one triple bond means, what does it mean? It means two pi bonds are there. So two pi bonds, to form two pi bonds, we have to remove two hydrogens from each carbon that are involved in triple bond formation. So two carbons are there. So two hydrogens you have to remove from the corresponding alkanes to form alkynes, and that is why general formula for a alkyne which contains only a single triple bond will be CnH2n plus 2 minus 4, because CnH2n plus 2 is the general formula for alkane. So CnH2n plus 2 minus 4, it means the general formula for an alkyne containing one triple bond is CnH2n minus 2. And if it contains two triple bonds, it means it will have CnH2n minus 6, because then two triple bonds, then you have to remove four different hydrogen atoms also from two different carbon atoms, and so it will become CnH2n minus 6. So CnH2n minus 2 minus 4, CnH2n minus 2 minus CnH2n minus 6. So in that way one can find out the general formula for alkenes and alkynes. And the alkenes and alkynes, if there is only one double bond and one triple bond, their formula will, usually we remember CnH2n plus 2 for alkane, CnH2n for alkene, CnH2n minus 2 for alkyne. So alkynes containing only one triple bond. The different examples that we know, Then there comes arenes. Arenes are organic compounds. The example is benzene, and the benzene structure is this. This benzene could be if the two fused benzene rings are there, like this. So this is naphthalene. Then there is the three benzene rings are there, second and the third anthracene. If the third comes here, then it will become phenanthrone. So there are many such examples. The multiple benzene rings they are fused together. They are all called arenes. And there can be substitution as well. All these positions there is hydrogen atoms, hydrogen 1, 1, 1, 6 hydrogen atoms are there. So one can also substitute those. They are all arenes. So usually, if the pure arenes, alkanes, or alkenes, these are the hydrocarbons. And what happens in an organic compound, one can also replace a hydrogen atom. Suppose I can replace this hydrogen atom with a functional group. So usually any heteroatom or any group, and if I replace that with the different groups, that is how we get a functional groups at different positions. And so if this hydrogen is replaced or substituted with one functional group, then we'll see that compound is actually known according to that functional group that is there in this compound, and that is because of the substitution that we see. So if you take the example of halides, halogen atoms are the functional groups. Then there can be fluorine, chlorine, bromine, and iodine. And this fluorine, chlorine, they can come with they are replaced with any of the hydrogen atoms, and that we know they are heteroatoms and they are functional groups. So then alcohol, if one of the hydrogen of the any of the hydrocarbon, in any of the hydrocarbons that we have seen, if any of the hydrogen is replaced with one OH group, then we call alcohol. There can be many OH groups which can take the positions of different hydrogen atoms and different positions in the carbon chain. So they are all alcohols. If hydrogen atoms of the hydrocarbons are replaced with CHO groups, then we call, if only CHO groups are there or one CHO group is there, then we call such compound is as aldehyde. We recognize them as aldehyde, and the functional group is aldehyde. And what is the group is CHO. CHO is also C double bond O and then CH bond is there. So one carbon, double bond O and then H. And then the ketones, what we know, if the ketones are also the functional group, and these ketones are formed, the compound is called ketone when two different alkyl groups are attached to this C double bond O group. And what are the alkyl groups? If you that we'll see a bit later. So alkyl groups, if you replace one hydrogen atom, remove one hydrogen atom from the alkane, then whatever the remaining group will be, that is called alkyl. So if I remove one hydrogen from here, that is also alkyl. If I remove one hydrogen from this position, that is also an alkyl. There are different alkyl groups because of their positions from where the hydrogen atoms are removed. And so if these one alkyl group and similarly another alkyl group is attached or linked to this carbon atom, which is called a carbonyl carbon, have a carbon C double bond O is called a carbonyl group, and this is the carbonyl carbon. The two different alkyl groups are linked to this carbonyl carbon. Then this functional group is called ketone, or such compounds are also called ketones. And the aldehyde, only one alkyl group is attached to CHO group. It means this CHO group will be at the always at the terminus, and this comes in the middle of the carbon chain. Then similarly, if the hydrogen is replaced with a CN, we call nitrile functional group. If oxygen atom, one heteroatom oxygen, it sits between two different alkyl groups, and this R is alkyl, this R is also alkyl, and then we call such a functional group as ethers. Such compounds are called ethers, and this is ether functional group. Then the carboxylic acid, the hydrogen atoms of the organic compound or the carbon chain is replaced with or is substituted with C double OH group, then we call such functional group carboxylic acid. So this C double OH group is called carboxylic acid functional group, and the compound is called carboxylic acid. General, the carboxylate, what we know, if one alkyl group is attached connected here, these are ions. Here it means if you the carboxylic acid, if you remove one H plus ion from the carboxylic acid, you will get carboxylate ions. And usually what we know, if the H plus is removed, we name all the anions are usually named. Most of the anions are their name comes with the ATE, ends with the ATE. There are also certain anions that ends with ide or ide. Usually the anions containing more than one carbon, more than one atom, that are polyatomic anions, their names comes as the 8 or I. It ends with 8 or I. Usually IDE comes with the anions which have only one atom. The monoatomic anions, their names end with ID, sulfide, oxide, nitride, bromide, chloride, and so on. Otherwise, you say sulfate, sulfide, carbonate, nitrate, nitrite, and so on. Perchlorate, chloride, hypochlorate, and so on. The chlorate. So 8 and I polyatomic anions, their name ends with AT or IT. So if you remove H plus, and this will become anion, and that we call the carboxylate ion. So this anion is called RCOO minus is called carboxylate anion or the ion. Then we see esters. It means in the carboxylic acid you replace this hydrogen with the R group, or you replace one of the hydrogen of these hydrocarbons with COOR group. R group is also an alkyl group. Then such compounds are called esters, and this functional group is called ester functional group. Then the acyl halide, but we know from the carboxylic acid, there are derivatives of the carboxylic acids, and one can easily understand the carboxylic acid. You remove this OH group and add one halide, then it will become aryl halides. And then amines one can consider they are derivatives of ammonia, and ammonia, if one alkyl group is connected to one hydrogen of the ammonia is replaced with one alkyl group, then it is called primary amine. If the two hydrogens of the ammonia are replaced with two alkyl groups, they are secondary amine, and all the three hydrogens of ammonia replaced with the three alkyl groups, they can be same or different, then we call tertiary amine. So primary, secondary, and tertiary amine. And then amides, what we know, the carboxylic acid RCOOH or RCOOH, if this OH group is replaced with NH2 group, the amide group, then this functional group is called amides. And amides can also be primary, secondary, or tertiary. If this is the OH group is replaced with NH2 group, then we call amide. Or if this H group, OH group was of the carboxylic acid was replaced with NHR group, then secondary amide is called primary amide, and this is tertiary amide. Means if amide contains two hydrogens, it is primary amide. If the amide contains nitrogen of amide contains one hydrogen atom, it is secondary amide. And if the nitrogen of the amide group contains no hydrogen atom, then it is and only alkyl groups, and it is called tertiary amide. Then this functional groups, this is also polyatomic functional group. This could be NO2, or this functional group can be SO3H. And what we also have seen that in case of polyfunctional compounds, this I am repeating because what we know the students get confused. They do not remember this functional groups, and if you do not recognize and remember their structure, the functional groups, you will find difficulty in writing IOPS nomenclature, even in understanding isomerism, and so you may not understand any organic chemistry. So these functional groups are actually these are A, B, C, D, they are alphabets of organic chemistry. So you must understand, you must remember all these alphabets, all these functional groups of organic that can exist, the general functional groups in an organic compound. So in the case of polyfunctional compounds, one of the functional group is chosen as principal functional group. This I have already explained. So if there are many functional groups that are there in an organic compound, then we'll see which functional group is the principal functional group. Means if I change the chemical conditions and put this organic compound under a typical condition, which of the functional group will react first? And based on that, which one will react first, then one can decide the priority order or the preference order of their reactivity. And that preference order of their reactivity actually also tells which of the functional group is the principal functional group. The functional group which is most reactive is the principal functional group in the given polyfunctional organic compound, and the rest of the functional groups are called subordinate functional groups. And these subordinate functional groups, they behave usually as branches that we have seen in hydrocarbons. The hydrocarbons, we know they can have branches, and these subordinate functional groups are treated as branches in that organic compound. And that we see this is a branch in that this organic compound. We'll see these are two different branches. One can see this as a principal chain or this as a principal chain. So two methyl groups will be there as branches. So they are branches of the substituents in writing IOPC nomenclature or usually also seeing the chemical reactivity of such compounds. Let us now see the nomenclature of organic compounds. In the nomenclature of organic compounds, we will mostly focusing on the IOPAC nomenclature of organic compounds. This IOPAC means International Union of Pure and Applied Chemistry. This name, the full form you should remember, International Union of Pure and Applied Chemistry. This is IOPAC, and this IOPAC name is actually systematic nomenclature. This is also called systematic nomenclature, and a systematic nomenclature means if you know the name of the compound or the name of compound is given, you should be able to write the structure of that compound uniquely. Or if the structure of the compound is given, it should give a unique name to that compound, and that unique name is so that one can easily correlate name to the structure or structure to the name. However, the originally when the compound different organic compounds were discovered, they were given traditionally certain names immediately, and those names are called common name or the trivial name or the traditional names. And those names, since we know millions of organic compounds and all those millions of organic compounds, if you start remembering their names, it will be very difficult for you to remember. And with the name also remembering the structure and some other property, it is very difficult. That is why people have started giving a systematic nomenclature to organic compounds. And that systematic nomenclature, once you know the structure, you can easily write their name. And or you know the name, you can easily write the structure. And so how one can do that, we will see how the IUPAC nomenclature, how one can write an IUPAC name of an organic compound. And once you know those rules, there are different a set of rules. And once you know the set of rules, then you can easily write the structure as well from the name. So in order to clearly identify the organic compounds, a systematic method of naming has been introduced and is known as the IOPAC system of nomenclature. This IOPAC means International Union of Pure and Applied Chemistry, and in the IOPAC nomenclature, the names are correlated with the structure such that the reader or listener can deduce the structure of the compound from it and from the name. So before the IUPAC system of nomenclature, organic compounds were assigned names based on their origin or certain properties. However, if you look at certain examples, the citric acid, you know citrus fruits, citrus fruits like oranges and lemons, there are citrus fruits, and the acid that is found in these citrus fruits are called citric acid. So based on the origin from which type of fruits and the plants this acid is extracted, so it is called, it is citrus fruit, so people say that acid is citric acid. So these are common names, and these are derived from the origin of these compounds or the certain properties of these compounds. And another example is the formic acid. The formic acid was initially it was extracted from the red ant, and red ant, their Latin name is called, Latin name of ant is formica, and from the formica the name is derived as formic acid because this is an acid, it is sour in taste and other properties are also like an acid, so we call it as a formic acid. So this is how people had given name initially when these compounds were initially discovered or the isolated or the they have been extracted from the natural resources. So these names that comes from the origin of the compounds or the certain properties which are based on that, these names are traditional names and they are also considered as trivial or common names. And some of the common names, although it is, but we know that common names may not tell you the from the name, you may not derive the structure of the compound. But some common names are so famous that they are even important today, and they are also followed in chemistry and many other books as well as in your exam for your exam purposes. Their name is also important. So some common names are so famous that they are followed even today. And for example, if you to look at the Buckminster fullerene, Buckminster fullerene is the C60 name of the C60, and this name is the common name, and this was given based on the name of the discoverer, who was the Buckminster Fuller, and so this is called Buckminster fullerene, and this the name, the common name is given based on the name of the discoverer, and this name is still used for the C60. So common names, some other common names, if you know the methane, the common name is methane CH4, the compound CH4. This is still used today. Ethane was also a common name. Propane and butane, up to butane, it was the common name. initially the primary name that was given. Later on, we have seen other alkanes and systematic name is given. So common names are useful in cases when the alternative systematic names are large means so lengthy and complicated. If the alternative names are very lengthy, very large, so what people do, they still write few words and few things. They write still common names. So the common names are that is why very still in use and they're important. Some compounds having common with the common names and the compounds are given here in the table. So CH4 is methane. You should remember, you write the structure CH4 and methane. You should remember this H3C, CH2, CH2, CH3, or this is we can also call CH3, CH2, CH2, CH3 is N-butane. And this compound, this CH3 CH3 twice CH3 is called isobutane. So if there is a branch that we call butane and isobutane, if you look at the structure of this compound, this is isobutane. And if this CH3 group was here and this CH2 CH3 and this was also CH2, then it was a butane. So butane, and that butane is also called the straight chain butane, is N-butane, we call N-butane, normal butane, and this is as isobutane. So normal butane or N-butane, so this is the butane or the N-butane. And what we see here in this case is N-butane and this is isobutane. So this is the straight chain compound and this structure of this compound is that we have seen, isobutane. Then the pentanes can also be N-pentane, isopentane and neopentane. So this is the new N-pentane is CH3, CH2, 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 CH3, 5 carbon atoms. So pentane, N-pentane. Then if you have this kind of branch, that branch we call isopentane, and then we can have neopentane. So if there is only one branch and the 4 carbon atoms in the go and one branch somewhere, then we call isopentane, and then two branches are there and then we call neopentane, and the structure of the neopentane we have seen earlier. This is the neopentane. If this one of the CH2 group is here, then that structure will be isopentane. So these names, the common names, are also important for these compounds. And then we see CH3, CH2, CH2OH, then propyl alcohol. This is a formaldehyde. This may not be that important, but formaldehyde is important. HCHO. If this is CH3, CHO, then it is acetaldehyde. These names are common names and they are still in use. If this is HCOOH, then it's called formic acid. From the formaldehyde, formic acid that we have just seen here, the extracted from the red ant. So formic acid, HCOOH. If it is CH3COOH, it is acetic acid. And then CH3 twice CO, acetone. These names also given here. Once you know their structure and after writing their structure, it will be easy for you to remember. You may not have to actually mug up these names. It will come automatically to your memory. But you should initially try to remember these names. So CH3 twice CO. If you, this is what CO, then CH3 CH3. This is the ketone functional group, and this is the simplest ketone is the acetone. The two CH3 groups, what we have seen the ketone functional group as here, C double bond O, the functional group, two alkyl groups should be attached to C double bond O. And what we know, the simplest alkyl group is the methyl, so two methyl CH3, CH3, so that is acetone. So the acetone that we have seen here, acetone. Then chloroform, CHCl3 is chloroform. You should remember CHCl3, one hydrogen and Cl3, then it is chloroform. And the acetic acid I have already explained. The benzene that we have just seen the structure, and in that structure what we know, the 6 carbon atoms, 1, 2, 3, 4, 5, 6, so that we know each carbon or each base there is a carbon atom and this valencies of the rest of the valencies of the carbon should be completed by the presence of hydrogen atoms, and what we see, this carbon has 3 valencies already occupied because of the carbon-carbon bond. So one hydrogen here. So similarly, one hydrogen will be at all the positions, carbon positions. So six carbon atoms, so 6 hydrogen atoms will be the C6H6. The benzene, and then we can have the benzene having one hydrogen of the benzene is replaced with OCH3 group, then we call it as anisole. If we replace the one hydrogen with simple CH3 group, then that compound are called toluene. It's called toluene. So C6H5CH3 is toluene. So in this benzene ring, what we know, one hydrogen, any of the hydrogens, let's see this hydrogen is substituted with CH3, then that compound is toluene. If it is substituted with OCH3 group, then such compound that compound is called anisole, and this is anisole, the common name is which is still in use. If the hydrogen is replaced with NH2 group, then we call such compound as aniline. If that one hydrogen is replaced with one OH group, then that compound will be phenol, that we know. And if what we know, if hydrogen, one hydrogen of the benzene is replaced with COCH3 group, this is the aromatic ketone. What we know, this is a kind of alkyl group, the aryl group. This is aryl group, and this is CH3 property is similar to the ketones, although their property, because they are again aromatic compounds, so their properties will be a bit different, but they are similar to the ketones. So they are ketones. The functional group is ketone here. So COCH3. So in acetone, one CH3 group and another CH3 group just replaced with the phenyl group. Phenyl group is what? C6H5 means one hydrogen is removed. So that is called phenyl group. One hydrogen of the benzene is removed, and that group is called phenyl group. So one CH3 of acetone is replaced with phenyl group, then that compound is acetophenone. This is acetophenone. So what we know, acetone. So acetone, instead of one CH3, if you remove from the phenyl group, so it will become phenone, acetophenone. Then this is the ether, ethyl methyl ether or dimethyl ether. One CH3 here, another CH3 here, the simplest ether, methyl methyl. That ether we call dimethyl ether. After if there was also one CH2 group here and this CH2 CH3, so CH3 CH2 O CH2 CH3, then that you can call such compound as diethyl ether. So this is ethyl methyl ether, ethyl, and then this is methyl and ether. Ethyl, then we know CH2 CH2 group is ethyl group, and this is methyl group. And how this ethyl and methyl name comes? So these names you should remember, and their substituents how they are called. This is the ethane, and if from the ethane you remove one hydrogen, then that group, the alkyl group, is called ethyl group. So what we do, the ethane ANE we remove and we add YL. So it will become ethane. So from ethane you remove ANE and just add in position of ANE YL. So it will become ethyl. If it was a methane, so ANE you replace with I, so it will become methyl. If it was a propane, so you remove the ANE, it will become propyl, butyl, pentyl, and so on. So these things we have already seen. So now let's see the IOPS system of nomenclature. The IOPS system of nomenclature, they are based on certain rules, and those rules we should remember. And first of all, what should we do? We should identify, to write the IOPS nomenclature, we should identify a parent carbon chain, and then what is the functional group in that compound, and what are other substituents that are added to the organic compound. So what we see, the largest continuous carbon chain we have to identify. The largest continuous carbon chain is called the parent chain or the principal chain. Then we look at the functional groups, and then the functional groups we look at the, if there are more than one functional group, then we look at this priority order, this order of preference on this. And so the functional group which comes first in this order is more reactive, and so that is the primary or the principal functional group. And so if you look at the OH group, OH groups are here, and alkyl groups are even, the alkyl groups that they name are not given here in this order. So it comes, alkyl groups comes even after amines. So alkyl groups are there. So alkyl groups, so what we see, the alkyl groups are there. Although their functional groups, their reactivity is less than the other, this alcohol. So the alcohol is the functional group, the principal functional. This is also functional group, but this is the subordinate functional group. And this methyl group, this is called a branch or the side chain. So there can be the largest chain, even if I didn't consider this CH3 group and up to here, this is also parent chain. So, and this is can be considered as substituent or the branch. And if you consider the principal chain in the straight line, so this is considered as a branch. So this is branch, this is the functional group, although the subordinate functional group, this is the principal functional group, and so on. So a systematic name of an organic compound is generally derived by identifying the parent hydrocarbon and the functional groups attached to it. And so the parent hydrocarbon and the functional group you should identify, you should note. And once you have noted the parent chain and the functional group and also the substituents, there are certain words that we use and that are called prefixes. With the help of prefixes and suffixes, one can write the name of the organic compound. So any name or any word contains something in the which is the initially added initially and later on finish. So that comes something which comes initially, initial part of the word are called prefix, and something which comes later on that called suffix. So by using the prefixes and suffixes, the parent chain name can be modified to obtain the actual name of the compound. So in Hindi, what we have the upsarg and pratyay. So similar things of prefixes and suffixes are there. So hydrocarbon, and what should we know that the compounds containing carbon and hydrogen only are called hydrocarbons. So parent hydrocarbon. To understand parent hydrocarbons, you should remember this compound, this chain contains only carbon and hydrogen and not the heteroatoms. Once the heteroatoms comes, that might be the part of that, usually is the part of a functional group, and based on what is the structure of that, we should decide what is the functional group. If it is OH, it is a functional group. If it was CHO, then CHO was the functional group. If it is Br, this is also a functional group. So what also we know that hydrocarbon is termed saturated if it contains only carbon-carbon single bond, that we have seen. So carbon-carbon single bond, it is saturated hydrocarbon, and we name such hydrocarbons as alkanes, the common name. If the in the IOPS nomenclature, and this homo is also can be considered alkanes as the homologous series, and these alkanes are also called paraffins, and this paraffins means little affinity, and these were the earlier names given to these compounds, the alkanes. They are paraffins, they have very little affinity with each other, and then unsaturated hydrocarbons are there, and unsaturated I have explained earlier. Unsaturated hydrocarbons means there is some multiple carbon-carbon bond that exist in the hydrocarbon chain, and that is called unsaturated hydrocarbon. But please remember, unsaturation doesn't mean the aromatic groups. Aromatic groups are not considered unsaturated, or aromatic compounds are not considered as unsaturated, like benzene. Although it has multiple three double bonds in its structure, but it is not an unsaturated compound. This is not an unsaturated compound. This is an unsaturated compound. This is also an unsaturated compound. There are many other compounds which are also, this is also an unsaturated compound, although this is cyclic. This is cyclohexene. But these compounds, which are aromatic compounds, they are not an unsaturated compounds. So cyclic compounds which are aromatic are not considered as unsaturated. So cyclic compounds, alicyclic compounds can be unsaturated, or the aliphatic compounds or the open chain compounds are unsaturated. So unsaturated hydrocarbons are those which contains at least one carbon-carbon double or triple bond, and in the degree that we see, the degree of unsaturation, we will see even one ring is also considered one degree of unsaturation. So unsaturated hydrocarbons containing only double bonds are also called olefins. So this thing we have also explained earlier. So if it contains a hydrocarbon contains only carbon-carbon double bonds, and this is unsaturated. So such compounds are called olefins. Olefin, this word has come from olefiant, and the Latin word, and this olefiant means oil producing. So now let's see the IUPAC nomenclature of alkanes or the saturated hydrocarbons. And this alkanes itself, this name alkane is what? It's IUPAC nomenclature. Initial name was, the earlier name was paraffins. And so what we see, these alkanes can be straight chain hydrocarbons, and they can also be the branch. And they can also be branched chain hydrocarbon. So a straight chain hydrocarbon, we can see here, this is a straight chain hydrocarbon. Means CH3, CH3, CH3 groups are, one can, in the single chain, one longest continuous chain will contain all the carbon-carbon atoms. If any chain with the continuous chain cannot number all the carbon-carbon atoms continuously with one nomenclature, then it means there is certain branching. So what can I do to find out the straight chain? If I just start giving numbering from one end to the another end, so 1, 2, 3, 4, and if I end any, even if this CH3 group is shown here and this hydrogen here, What can we do? I can show this hydrogen here and this CH3 here. This is just a different conformer. And so that is also the same carbon, the same state chain hydrocarbon. But if you see this hydrocarbon, this is butane, N-butane, and this is also a butane, this is isobutane, the common name. So this isobutane, what we see, if you look at the numbering one end to another end, one, two, you can go here three, so this will be left as a branch, or one, two, three, so this one is left as a branch, and the branching both in this numbering at the second position. So this is what we call this a branch chain hydrocarbon. So the names of state chain hydrocarbons are very simple, and then we look at the from the state chain hydrocarbons later we will see. We also see the branch chain hydrocarbons. And name of the branch chain hydrocarbons are very important when we will see, to note that because similar rules will be used for naming the organic compounds having functional groups as well. Only the thing is, for the functional groups we will add some extra uh, letters to the name, and some other root words to that name, other suffixes to that name. So anyway, those things we will see for the functional groups. Let's first see the IOPS nomenclature of straight chain hydrocarbons. Usually for the straight chain hydrocarbons, what we see, we use a prefix and then a suffix. Prefix depends on the number of carbon atoms in the longest continuous chain. So we have to first identify the longest continuous chain, and in the longest continuous chain, then we have to, based on that longest continuous chain, we use certain prefixes, and those prefixes you have to remember, and anyone will have to remember, and that is not difficult to remember. It comes automatically. Once you write two three times, it will be remembered. And then a suffix will be in. So all kind of saturated hydrocarbons with suffix in will be common. So all the names, all the saturated hydrocarbons, their name will, IUPAC name will end at in. So it is methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, undecane, dodecane. There you can, as you can see, the name ends at ane. So this, it means that this compound, organic compound, or this hydrocarbon is a saturated hydrocarbon. And from the ANE, only this information we have understood, that there is only carbon-carbon single bond that exists in this organic compound. And then the carbon-carbon single bond, that we understand how many carbon atoms are there in that compound. And if you also know the number of carbon atoms, and if you know this organic compound is saturated, then the hydrogen atoms you can add accordingly, because you know the saturation, the tetravalency of the carbon. Since the rest of the valencies, other carbon-carbon bonds are completed because of the presence of hydrogen atoms. So you can also write the name of that state chain, alkane, or the hydrocarbon. And so what we know, these prefixes are based on the number of carbon atoms that are present in that organic compound, the state chain hydrocarbon. And so if there is only one carbon atom, then we add prefix as meth. If two carbon atoms are there, then prefix will be eth, that is here. If three carbon atoms, the prefix will be prop, up to here. If four carbon atoms are there, then prefix will be but. So but plus n, the prefix plus suffix, butane. And there is no gap that we put between prefix and suffix, and usually we write all the words similarly. So prop plus n, propane. Eth plus n, ethane. Meth plus n, methane. And please remember, these prefixes from methane to butane, these prefixes are actually based on the common name of this compound. And after that, we look at the root words, and it depends. It actually notify the number of atoms. The pent means, we know, if pent means 5, hex means 6, hept means 7, oct means 8, non means 9, dec means 10. So these are words that are used for dec means 10. These are already root words, and these things we have seen earlier as well. For the single one, it is in or on, that we have also seen when writing IOPAC nomenclature of elements having atomic number more than 100, from 100 onwards. Usually we, IOPAC has also suggested certain onium, like we have seen. So nil, 0 is nil. So onium means 1, 1, 1, 111 atomic number. So 1 means 1. So this die, or the mono is also a word for that, we use root word for the one. So the die that we know usually, die is for 2, tri is for 3, tetra is for 4. But these, from meth to eighth, this meth to but, these words, the prefixes are taken from their trivial names are the original, the common, sorry, not original, common names. So what we see, the straight chain hydrocarbons name, the names of such compounds are based simply on their chain length, and based on the chain length means the longest continuous chain. So if there are four, chain length is what, four carbon atoms are here in the chain length. So four carbon atoms. So this compound that we know but is for four, and N is because this compound is saturated. So this will become butane, and the common name is N-butane. And this compound, as we see here, this is a branching. So their name, this name of this compound, we'll see how one can write the name of branch chain hydrocarbons, and that this example we'll see later. The common name that we know, this is isobutane. So this one of the CH3 group you replace, I just put it in the middle of the chain. So three carbon atoms will be only there. If you remove this, so the one hydrogen you have to put to complete the valency here, and this hydrogen should be removed, and this CH3 group should be placed, so it will become isobutane. So anyway, so if the states in hydrocarbons, there's names that we write based on the chain of length simply, and it ends, the names of the states in hydrocarbons ends with ane, which is called a suffix, and also carry prefixes, and this prefixes indicates the number of carbon atoms present in the chain and the longest continuous chain. And what you remember, that this number, these numbers which actually from the paint 5 hex, usually the except from ch4 to c4h10, where the prefixes are derived from the trivial names. These prefixes from meth, eth, prop, but, they are derived from the trivial names of these compounds, methane, ethane, propane, and butane, and not from the number of the carbon atoms. From the numbers from here, from the paint hex, these numbers denotes this paint hex or something like this. But you should remember, but here, it but means 4, prop means 3, eth means 2, meth means 1 here in this case, although these are not derived from the, and although these are derived from the trivial names of the given compounds. The IUPAC names of some station saturated hydrocarbons are given here, and what we know is the seven carbon atoms in the chain, like CH3, CH2, 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 CH3. Then it will become heptane, seven carbon atoms. The octane, if the 8 carbon atoms, nonane, 9 carbon atoms, decane, 10 carbon atoms, undecane, 11 carbon atoms, dodecane, 12 carbon atoms, icosane, 20 carbon atoms, tricontane, triacontane is for 30. So this is how one can write the names of saturated hydrocarbons, and please remember that this series is also called the homologous series for alkane, and what we see in the successive members, there is a difference of CH2 groups. What is CH4 and this is C2H6. If you remove this, and C2H6 minus CH4, the what will be CH2. Here successive member C3H8, C2H6. So this is CH2, difference of CH2 groups, and you see here up to decane, they are part of homologous series. They are successive members, and this is also part of the alkane homologous series. But the thing is, they are not the decane and icosane are not successive members. So that is how you see the difference is much, and this difference will be 10 into CH2, and so the difference will be C10 and H20. CH2, that is how over the C10, if 3 become 10, so H will become 20, 2 into 10, 20. So the difference, this is how we see, because the difference is the difference of 10 members. So successively 9 more members are here between decane and icosane. And similarly, between icosane and triacontane, there are also 9 members that comes between them. So there is also difference of C10, H20 that you see here. So the successive compounds in this table differ from each other by merely the number of CH2 groups in the chain up to decane, and from here, from decane, they are not successive members. So they are also called homologous alkane series, and each member is called homolog. So they are also homologs, although the few members are not written here. Now let's see the how one can name the branch chain hydrocarbons. And as I said, the naming of branch chain hydrocarbon is very important, because from the naming of the branch chain hydrocarbon, the similar rule, similar pattern we follow for all naming, or to name all other organic compounds containing even functional groups as well. The similar pattern we follow. So the most of the rules that we see here, they are very important. So in a branch chain compound, let's first see what is the branch. So in a branch chain compound, a small chain of carbon atoms, which are also called branches or side chains, are attached at one or more carbon atoms of the principal chain. The principal chain is what, or the parent chain is what? Principal or parent chain. The longest continuous chain is the principal or the parent chain. And what we see at the more than one or more than one positions, the hydrogen atoms are replaced with some other group, the carbon or the chain of carbon atoms, and those chains are called branches. And what are the branches, and how will we decide which is the branch, that we'll see later. So for example, if you see this compound, what we see, CH3CH, and we see CH3 group here as a branch, CH2CH3. So this, the parent chain contains four carbon atoms, one, two, three, four, and one carbon atom is there in the branch. So this was, if this branch was not there, there it would have been CH2 group. So one hydrogen of this CH3, CH2, CH2, CH3 is now substituted with CH3, so it contains five carbon atoms. So usually it should be pentane, and so since substitution is here, this is called isopentane. So this compound is isopentane, that we know. So usually the common name. Now this, let's see this compound, CH3, CH, CH2, CH, CH3, and two substituents are here, CH3 and CH2, CH3. Then how will we define which is the parent chain and or the principal chain and which is the substituent or the side chain or the branches? So to determine that, we have to first find out the longest continuous chain. So always remember, the longest continuous chain is the principal chain or the parent chain. So longest continuous chain, if I start counting the number of carbon atoms from here, this end to this end, I'll see 1, 2, 3, 4, 5 carbon atoms in the longest chain. And if I start counting from here, 1, 2, 3, 4, 5, 6 carbon atoms are there. So this chain is the principal of the parent chain, and this CH3 group is the branch or the side chain, and this CH3 group is also side chain. Even if I counting, if no, I do not go here, 1, 2, 3, 4, 5, and 6 here. So this was also 6, this is also 6, so you can go anywhere. So this CH3 group, if you go from here to here, so this CH2 group will be in the branch, and this is the branch. You cannot tell that the 1, 2, 3, 4, 5, this, so the only 5 carbon atoms in the principal chain, and CH, this is the ethyl group as a substituent of the side chain, and CH3 group. That will be a wrong notion. So nomenclature, you should always consider the longest carbon chain as the longest continuous carbon chain. The continuous is also important because the longest chain you can count randomly. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then you can come here 7 and this 8. But this is not continuous. There is no continuity from here to here and then here. So longest continuous chain is, as written here, the longest continuous chain. So longest continuous chain determines the principal chain, or is called as the parent chain or the principal chain. So the longest carbon chain is, and the longest continuous, I should also write longest continuous. So longest continuous carbon chain is identified as a principal chain or parent chain, and the small chains or the branches are called alkyl groups. So in order to name branch chains, so what we have to, we should also follow certain rules to name these branches or branch chains or the side chains. And these names, the rules and these groups are also called alkyl groups. So a small chain of the branches are called alkyl groups, as I have been naming the ethyl, methyl, propyl, which I have already explained. So in order to name branch chain compounds, the names of alkyl groups are prefixed to the name of parent alkane. So name of alkyl group is prefixed to the name of parent alkane. So what we do, if you look at these rules, CH4 methane. So if you remove one hydrogen and if the branch, there comes along the chain, the main chain or parent chain, and so what we have to do to connect this CH4 group to a carbon chain, we have to remove one hydrogen to create a valency, to create a vacancy, so that the carbon atom can get linked to that carbon atom. So we have to remove one of the hydrogen, and so that is this group is called methyl because methane, the name was methane. If C2H6, that we know C2H6 ethane, and you remove one hydrogen, it will become ethyl. And this removed hydrogen, so this is the vacancy which is created, and from here this group will be connected or linked to the parent carbon chain. And so this is propane, and if this see the here the well can see, and so this is called propane, from propane to propyl. So what we are doing, we are removing ane and adding yl. So methane became methyl, ethane became methyl, propane became propyl, butane became butyl, decane will become decyl. So ane removed ane and add yl. So decane will become decyl, pentane will become pentyl, hexane will become hexyl, and so on. So this is how the one can identify the alkyl group, and so these groups are called alkyl groups, which have one vacancy, and from this position, this group gets connected to the principal or the primary the chain or the parent chain. And what we know also, these groups have also can also these branch substituents or the side chains can also have branches, and based on the branches their common names as well be used. And what we know, this was CH3 if this group is attached to the parent chain, then we call it the isopropyl group. The propyl group, if this was the vacancy was here, then it was propyl group or N propyl group as we see here. CH2, CH2, CH3. So if the vacancy was here, then it is called propyl group or N propyl group. If vacancy is at this carbon atom, then we call it as isopropyl group. And what we see, if the vacancy is at this carbon atom instead of this, what we see, this is the same chain. So it doesn't create any difference with this. So vacancy is either at this carbon atom or this carbon atom, they are the same. So this is isopropyl group, and the butyl group. What we know, butyl group can have butane, can have branches as well. So butane, N-butane. So N-butane. So the butyl group that we are adding, this is the N-butane. So vacancy is at this end or at this end. So this is butyl group, and if this butane group, the vacancy can be here as well at this position. And this position, this is called secondary butyl group. And why the secondary butyl group? I'll explain a bit later. So this is the secondary butyl group, or what we can see the isobutyl, the isobutyl structure. This is isobutyl group, and what can we do? This position, at this position as well, one can add this the parent chain. So this will called isobutyl substituent. And then if the substituent, and if not this carbon will also, all these one these terminal carbon atoms are the equivalent to create vacancy here, here, or here, it is the same isopropyl group. But if you create a vacancy here at this position, what we see, this is a tertiary carbon atom, so that is called tertiary butyl group. So tertiary butyl group, so tertiary butyl group is shown here. So CH3, if you remove here, this is because of the branch that we see in the butyl group. This is tertiary butyl group as a branch. And one can also use the systematic way of naming these branches as well. However, these trivial names of the alkyl groups are also used in IOPS nomenclature, so you should also remember these names. And sometimes you may see these names, they are actually being used in the IOPS nomenclature. This is the neopentyl group. I'll explain them in a bit. Let's first see what is the primary, secondary, tertiary, and quaternary carbon atoms. So primary carbon atoms, usually what we see in the carbon chains. Here, if a carbon atom is connected or linked to only one carbon atom in the organic compound, then that carbon atom is called a primary carbon atom. So this carbon atom is linked to only one carbon atom in this chain. So this carbon atom is the primary carbon atom. So this carbon atom is also primary carbon atom because it is also directly linked to only one carbon atom. This carbon atom is also primary carbon atom because this is also linked directly to only one carbon atom. However, if you look at this carbon atom is directly linked to two different carbon atoms. One carbon atom here on the left side and one carbon atom on the right side. So this carbon atom is called secondary carbon atom. So this is a secondary carbon because it is linked to two different carbon atoms. In this compound, we also see this carbon atom is linked to two different carbon atoms here. One carbon atom, one carbon atom. So this carbon atom is also called secondary carbon atom. Now what we see, the carbon atom can be linked to three different carbon atoms, and same three means tertiary, and so that carbon atom is also tertiary carbon atom. And what we see in this compound, this carbon atom is tertiary carbon atom. So CH3, this is one carbon, this is linked to this carbon atom, 1, 2, and 3. So this is directly linked to three carbon atoms. So this carbon atom is the tertiary carbon atom. So if we look at this butyl group, this carbon is actually tertiary carbon atom, and so this is called tertiary butyl group. Because the branch is at this branch is linked to the parent chain at the tertiary carbon atom, so this is called tertiary butyl. In this butyl group, what we see, this butyl group, this carbon atom is a secondary carbon atom because it is directly linked to two carbon atoms here in the butyl group, not in the original compound, because in the original compound this carbon atom was already linked to certain carbon atom, so this will be tertiary carbon atom. But in this form, in this side chain, if we isolate the side chain, what we see, this side chain in the isolated form, it is connected only to two carbon atoms, so this is a secondary, and this is butyl group, so this is secondary butyl group because this group contains four carbon atoms of butyl group and the secondary butyl group. Why isobutyl? Because we have seen the isobutyl is actually, it has a structure similar to this propyl group, and the isobutyl what structure we have already seen here. So similar to this, what we see, this CH2 group is now this connect to this. This, even if this hydrogen, not this is CH3 and this was CH2, this is also isobutyl. If this was also CH3, this 2 were CH3 and this is CH2, then this is also called isobutyl. So isobutyl, what we see, this group is connected here. This is isopropyl, and this is isopropyl group is connected to CH2 group. Then we call it such group as isobutyl group. So isopropyl group linked to CH2 atom, and so there is a vacancy here. So this is called isobutyl group. So I hope you understand why this is named the tertiary butyl, because this carbon atom is connected to three carbon atoms in the side chain. So this is tertiary carbon atom, and this is butyl group because it contains four carbon atoms. So it's tertiary butyl. Why this is secondary? Because this carbon contains four four carbon, this carbon atom is linked to two carbon atoms directly, and so this is secondary carbon atom, and so the side chain which contains, which is linked to the main chain or the parent chain, we also call that parent chain or the principal chain or the primary chain or the main chain. We also call the main chain. Some books also follow them as that it as a main chain. So this, if it is linked to the main chain, the carbon atom is the secondary carbon atom. So this is the secondary butyl group. Now what we see in this example, this carbon atom is linked to four different carbon atoms. So this carbon atom is called quaternary carbon atom. So this carbon is quaternary carbon atom, but please remember this carbon atom is not linked to the main chain or the parent chain or the principal chain or the primary chain. So this group is what this we call, because this entire compound is called a neopentane. Neopentane structure we have seen earlier somewhere. There is a neopentane, so they replace this hydrogen, one of the hydrogen, this will become neopentane. So this carbon is what? The quaternary carbon, because this carbon is directly linked to four different carbon atoms. This carbon atom is tertiary carbon atom because this is linked to three different carbon atoms, and these are anyway carbon atoms of the functional group. So in this is secondary carbon, this is also secondary carbon, this is primary carbon, this is primary carbon. And so in this primary, this is secondary, this is secondary carbon atom, this is primary carbon atom, this is primary carbon atom, this is tertiary carbon atom, this is primary carbon atom, this is primary carbon atom, because as we see, this is linked to only one carbon atom directly, and so on. So in this example, so we have seen primary, tertiary, secondary. Here primary, this is primary, this carbon atom primary, this is primary, and then we see secondary carbon atom. This carbon atom is secondary because on one side it is linked to this carbon atom, one side this carbon atom. So this is secondary carbon atom. This is also a secondary carbon atom. This carbon atom and this carbon atom, these two carbon atoms, this one and this one are tertiary carbon atoms. So you should remember this primary, secondary, and tertiary carbon atoms, and this nomenclature is important because what we see, also the similar things we use also for the for the halide groups or the halogens that are connected as a functional group, or the alcohol. So primary alcohol, we write certain common primary alcohol, secondary alcohol, tertiary alcohol. So if OH group is connected to the primary carbon atom or linked to the primary carbon atom, means the carbon atom is directly linked to only one carbon atom, then that alcohol is called primary alcohol. If the OH group is linked to the secondary carbon atom. The secondary carbon atom is the carbon atom which is directly linked to two different carbon atoms. Then that alcohol is called secondary alcohol. And if OH group is linked to tertiary carbon atom, then the carbon atom which is directly linked to three carbon atoms are called tertiary alcohol. And we cannot have quaternary alcohol because carbon atoms can have carbon can have only four valencies, and if one valence is already occupied by the OH group, then the carbon has only three valencies that are left and which can be added to the carbon atom. So the any carbon atom which is already linked to OH group cannot have more than three different substituents, three different vacancies, and so we cannot have quaternary alcohol. So similarly, we can also call primary halide, secondary halide, and tertiary halide similar to the primary, secondary, and tertiary alcohol. Means the halide atom and the halogen atom connected to primary carbon atom, primary halide, secondary. If the halogen atom is linked to secondary carbon atom, secondary alkyl halide, or if it is connected to tertiary carbon atom, so it is called tertiary alkyl halides. These namings are important. We'll see in more details, and then certain rules. There are certain rules then we follow to write the nomenclature name of this. This thing we will see in our next class. The systematic nomenclature of the branch chain hydrocarbons. What are the rules and what are the few examples as well. We'll see in our next class. Time is over, so I'll stop here. So you should remember some important things: the primary, secondary, tertiary, and quaternary carbon atoms. You should also remember that what are the primary alcohol, secondary alcohol, tertiary alcohol, because these things will be very important and we will use later on in the organic chemistry. So primary, secondary, and tertiary halides, and also what are the branching, what is the main chain, how will you identify the main chain? The longest continuous chain is the main chain, or the principal chain, or the parent chain, or the primary chain, and rest all the carbon chains, the small carbon chains which are attached to carbon atoms here and there with the parent chain are called side chains or the branches. And the functional groups, what we know, the functional group usually contains either double bond or triple bond, or it contains heteroatoms in the carbon chain. So they are functional groups. And also what we know, hydrocarbons. Hydrocarbons, they can be alkane, alkene, alkyne, or the arenes. And the hydrocarbons there can have the branches and so on. So I'll stop here.